In this video, we're going to talk about some more properties that functions can have and look at how they relate to the graphs of functions. So the first two, we're not going to spend a lot of time on right now because they're the same as the symmetry concept we saw in an earlier video. The first is that a function can be called even if this equation is true. So what this means is if you ever plug in negative x into your formula, if you always get the same answer as if you had plugged in positive x, then the function is called even. However, this is the exact same as being symmetric about the y-axis. So it's really not a new concept, it's just a new name for the same concept. Similarly, we also have something called odd. An odd function is going to be when you plug in the negative x into a function and your output is the exact opposite of the output for the positive x. That is the same as being symmetric about the origin. So again, new name, same idea. We're not going to do any examples of that right now though. The things that we are going to focus on though is first off increasing and decreasing. So when we talk about, whether the number of new cases of disease is increasing or decreasing, that means as you go on through time, you're getting more or fewer cases of that. So in particular here, increasing means that as you go left to right on your graph, you are going up, whereas decreasing means as you're going left to right on your graph, you are going down. This one here, we're not going to deal with it that often just because it doesn't happen with a lot of formulas that we have, but it's possible for a function to be constant at part of it, and constant just means it's not going up and it's not going down. It's just staying completely flat right there. Now, once we have the ideas of increasing and decreasing, we can also talk about something called minimums and maximums. So minimums are the lowest points in your graph, and maximums are the highest point on your graph. And there's two varieties of them. There's a local min, local max, or an absolute min, absolute max. The absolute ones are the easier ones to understand. The absolute min is the absolute lowest point on your graph. The absolute max is the absolute highest point on your graph, whereas the local minimum is only the lowest point in an immediate area, and the local maximum is only the highest point in an immediate area. So for example, take a look around wherever you live and look to see if there's any hills or mountains nearby. Right? If you were to go to that mountain that's nearby and you go to the highest point on that mountain, you would be at a maximum. You're the highest point there. However, it is unlikely that you are at the highest point in the entire world, so it wouldn't be the absolute maximum. However, it is the highest point in your general area, so therefore it's a local maximum. So that's the difference between them. So here's a random graph of some function here, and I labeled several points on the function. Well, the first thing I'm saying is, where is this function decreasing? So I want to know, as I go left to right, where is it going down? Well, it starts out here. It is definitely going down up to here before it turns around. So that means everywhere to the left of -2, it is decreasing. It is also decreasing from this point down, down, down. All of those are decreasing there. And when we're talking about intervals for increase and decrease, we're talking about the x values here. So this x value starts at -1.3 and goes up to an x value of 1. We don't care about the y values in these types of problems. We're only saying for what range of x values is the function decreasing, going downwards. On the other hand, we also want to know where it's increasing, and that's going to be these two portions of the graph. That's where it's going up as you go left to right. And again, we need to write these as intervals for the x values. The first part, the x goes from -2 up to -1.3. And the second one, the x value goes from 1 up to infinity. So those would be all the places where we have an increasing graph. Okay, Now we need to look at local or absolute minimums. What are the lowest points here? Well, I see two kind of points that are low areas. Those are both low there. Now, which one is the absolute? Well, the absolute minimum, that would be this point down here. Now, when I ask for absolute minimum, you can tell me the value as in the point, or you could just say the absolute min is the y value -9. Both are valid ways of giving me the answer. The point is a little bit more descriptive, I would say. And then we also have a local min at the point -2, 0. It's the lowest in that immediate area. Now, if I want to find local or absolute maximums, I want to find the high points here. And I only see one of high point in that, and that's the point -1.38. But that is definitely a local max because it is not the highest overall of this function, because this function goes really, really high at both the left and the right ends here. So it's a local maximum, but it's not the absolute maximum. And in fact, there is no absolute maximum. There is no highest point overall because these graphs go all the way up. I know we don't see that. They only show us part of it, but that's enough for us to know that they keep going up and up and up, so that means there is no absolute max. And it is entirely possible that you will have no absolute max, or you might have no absolute min. It just depends on the specific graph or function that you're dealing with here.